In this video, I want to take a look at depth cuts whenever we're using a contour toolpath. And it's best to just go ahead and jump right in. We're going to go ahead and create a contour toolpath, and we're going to chain around this material. Now, as you can see on this particular drawing, I've drawn it in 3D wireframe using the translate join function. And when you're chaining, you just need to remember that when you're chaining wireframe geometry like this, it's best to come over here to C-plane so that it only references the construction plane instead of all of these 3D planes. I'll show you what I mean. If I just select that line right now, it chokes up right here. It says, I'm sorry, we're at a branch point. We don't know which way to go. So let's do that again. I'm just going to completely start over. We'll go to contour. This time I'm going to select C-plane, and your construction plane or your C-plane is this top plane right now. And you can verify that by looking down here at the bottom where it says C-plane, top. Okay, now that I'm referencing my C-plane as my mode for chaining, I can select that geometry, and you can see the geometry is completely selected 360 degrees around. Okay, we'll hit OK. And the tool that I'll use will be the 1/2" end mill. And my cut parameters I'm going to leave as default for now. I'm going to come to linking parameters, and I'm going to put in a depth of this distance, whatever this is. Now, if you've drawn this in 3D wireframe and you don't recall the distance that this is, which right now I'm blanking out, you can simply click this depth button, and then you can select that 3D space or 3D point, and you can see that it'll tell us that it's a -0.5. Okay, the next thing that I want to do is hit OK and verify the toolpath, and that looks good. If I watch that in verify, I face the part, and then it machines that contour. Perfect. Now the only issue is that that's a very big chunk of material that it's taking off all at once, and that leads us to the depth cuts. When we need to make a cut like this, many times it overloads the tool because of the amount of metal that it's trying to remove in one pass. So MasterCAM gives us several options for how to remove this material in smaller passes, and one that is very common is called depth cuts. Let's go into parameters, and then we'll go to cut parameters, and we'll verify everything looks good here, contour type, and we'll come down inside of this cut parameter dialog box, and we're going to go to depth cuts. We're going to turn that on, and then we have an option for maximum rough step. This is going to be the size of your depth cuts, and with experience you'll start to know what works and what doesn't per the diameter of the end mill. But just for this lesson, what I'm going to suggest is 50% of the diameter of the end mill, whatever the diameter of the end mill may be. And that is based upon if we were cutting aluminum material. So this is aluminum. I'm going to go 50% of the diameter of the tool, which that's pretty easy math, a 1/2" end mill. Our depth cut would be a 1/4 inch. But if it gets into a fractional dimension or something and you want MasterCAM to do the math, you simply type in the diameter of the end mill, 0.5, divided by 2 for 50% of the diameter of the end mill. And MasterCAM will do the math right inside the box. Okay, when I hit OK and I regenerate, you can now see that I've created 2 tool paths to get to that desired depth. This is called depth cuts, and it just simply reduces the amount of pressure that's on the tool per pass, taking the material away step by step. Let's increase that a little bit. Let's do 0.063. So we're going to do a 1/16 of an inch depth cut and take a look at that. There you go. You can see all the different depth cuts that it takes to get all the way down to the 1/2 inch depth of cut. And let's watch that in verify. Pretty cool, huh? That's how to machine away lots of stock without damaging your end mill without overloading your tool. Thank you.